In this lesson, we'll be evaluating functions. By the end of the lesson, you should be able to determine the range when given the function and a domain. So to determine the range when the domain's given, you just substitute the x values into the function, which is the rule or the equation. Those are your domain numbers, and the answers to the function are the y values. So to evaluate from a graph, f of 5 means the ordered pair is 5y, because f of x is f of 5, so that means 5 is x. So I go to my graph, I find where x is 5, and there's the y. So g of x equals 1 means that it's x1. G of x is y, so y equals 1. We're going to find x. So we go here to where y is 1, and we've got two numbers for x. Evaluate from an equation. F of x is in function notation, so remember f of x is the same as y. So f of 3 means we substitute 3 for x, and f of x equals 1 means to substitute 1 for y. So here we have three functions, and it says to evaluate f of 4. So we would simply put the 4 in for the x or the t or the a. So for example, what is the value of f of x? That means, or f of 6. That means x is 6, and what is y? Y is 0. Find the value of f of 2. We'll go to x is 2, and y is 5. Find the value of 3, f of 5 plus 1. So first thing we have to find is f of 5. So we go over here at f of 5, and that is 1. And then it's 3, so 3 times 1 is 3, plus another 1 is 4. If f of x is equal to 4, what's x? So y is 4, so that means all these. And so we actually have 3 values of x. How many x values make f of x equals 1? True. So here's our y equals 1, and so we actually have 3 times that it's crossing at 0, 5, and 7. For what x values is f of x greater than or equal to 4? So we want to look up here where it's greater than 4, so it's here between 1.5 and 2.75, and then greater than 9. Use the graph to evaluate the function. So f of 3, so we go to where x is 3, and that means y is 2. This one we go to where f of is negative 2, so x is negative 2, and y is 1. If f of x is equal to negative 1, that means y is negative 1. What's x? So we actually have two answers. Is this a function? Yes. Remember, y can be repeated. It's x that cannot. For each function, find the indicated value. So here we have f of x, and it says f of 4, so all we do is plug in 4 for x. Negative 3 times 4 is negative 12, plus 10 is negative 2. Same thing here. We plug in negative 9 for x. Negative 3 times negative 9 is positive 27, plus 10 is positive 37. Over here we did the same thing with h of x. It says h of 6. We simply plug in 6 for x. And h of negative 4, plug in negative 4 for x. If f of x equals 2x plus 5, find the value. F of negative 2, plug in negative 2 for x. Negative 2 times 2 is negative 4, plus 5 is 1. This one's a little more complicated because it says f of 1 plus 4. So we have to plug in the 1 for x and add the 4, and then add the 5. This one is the same, a little more complicated. Where it says x, I'm going to plug in the 2c plus 1. So it's 2 times 2c plus 1 plus 5. So we have to use the distributive property and combine like terms. If h of z equals z squared plus 3z minus 4, plug in negative 4 for z. Here, h of F5a, so wherever it says z, I plug in 5a. Can't combine these because they're not like terms, so you're just going to leave your answer as 25a squared plus 15a minus 4. In this one, looks very complicated, but all you're doing is you're going to, wherever it says z, I'm going to replace that with g, And then I have to multiply everything by 2. So wherever it says z, I replace g, and then I use distributive property and multiply across. Is f of x the domain or the range? F of x is the y, so it's the range. In this graph, what is f of 3? So I look where x is 3, and that means y is 2.